Sir, in the case of projectile motion, you are giving an initial velocity to the body. Based on the initial velocity, the body follows a trajectory. Trajectory means path of projection. You are giving some initial velocity. The body is thrown with a velocity. The body is projected with a velocity. Two different things here we have. One is body thrown from a height. Second is body projected from the horizontal ground level at an angle. Two different cases we are going to discuss here. Body projected from height. So first part we will see body projected from height. From here the body is projected with a velocity u. O, A, B. When the body is projected from a height with an initial velocity u, after a time of t seconds, it reaches the ground at the point B. So from this point to this distance, we call this one as range. Horizontal distance travel, that we call it as range. First, we have to prove path of the projectile. Horizontal distance x is equal to horizontal velocity into time. What is velocity here? U, and time is t. So I can write x is equal to ut. Displacement by time is called velocity. So velocity into time we call it as displacement. So t is equal to x by u. In vertical direction, the displacement is, what is basic displacement equation? S is equal to ut plus half at square. S is equal to ut plus half at square. Here, the vertical displacement S, you take it as y. In vertical direction, horizontal velocity has got no effect. That means u is equal to 0. In vertical direction, horizontal velocity has got no value at all. That is 0. Acceleration is replaced by g. So a is equal to g. So what will happen? Therefore, y is equal to half gt square. Y is equal to half g. What is t? My equation already we have written in terms of x by u. So I can write g x by u the whole square. So g x square by 2u square. G is constant, 2 is constant, initial velocity is constant. So I can write y is equal to kx square. Y is equal to kx square represents equation of a parabola. What is the meaning here? K is nothing but g by 2u square. It is a constant. Y is equal to kx square represents a parabolic equation. I don't know whether you know the parabola equation. Y square is equal to 4ax. This is the equation of a parabola. One variable square, one constant 4a, and another variable. Any equation represents like this, we call it as parabolic equation. Here you see y, one variable, x square, one variable, one constant. So this equation represents a parabolic equation. That means body projected from top of the building represents a parabolic path. First statement. Okay. Second thing, we have to calculate time of flight. TF. Throughout this projectile motion, we are going to consider the three equations. V is equal to U plus AT, S is equal to UT plus half AT square, V square is equal to U square plus 2AS. The three equations, depending upon where we are going to take, we are going to consider. Now we are going to take S is equal to UT plus half AT square equation. Sir, in this case, T is nothing but TF. S is nothing but the height H. S is H. This is vertical downward displacement. So initial velocity U is equal to 0. So what will happen? Of course, A replaces G. In the case of equations of motion, there is no acceleration. It is replaced by acceleration due to gravity. So A is equal to G. Substitute H is equal to half G TF square. TF square is 2H by G. TF is equal to root of 2H by G. Time taken by the body from a height of H till it reaches the ground is root of 2H by G. Time of flight. Next, horizontal range. First, we have taken path of the projectile and we have proved it is a parabolic path. And second one, we have done time of flight. Third one, horizontal range. Horizontal range means or horizontal velocity into time of flight. Simple. Distance is nothing but velocity into time, that formula. What is horizontal velocity? U. What is time of flight? Root of 2H by G. R is equal to U into root of 2H by G. Correct, Amma? So this is horizontal range. Next, resultant velocity. Resultant velocity. V suffix on. Sir, in the case of resultant velocity, this point Vx is the resultant velocity Vx. This is Vy. This is V suffix on, resultant velocity. angle is theta. Vx means horizontal velocity. Horizontal velocity, you know it is u. Vy we have to calculate. We know v is equal to u plus at. Here v is equal to vy. U is equal to 0. A is equal to G. Substitute. So, Pythagoras theorem, Vr square is equal to Vx square plus Vy square. Vr is root of Vx square plus Vy square. That is, Vr is equal to root of, what is Vx square? U square plus Vy square is what? Gt. V is equal to, substitute here, V is equal to Gt. That is nothing but Vy. So, G square. This is resultant velocity of a body or a projectile projected from top of the building. Clear? So, in projectile motion, ball thrown from a height, any body thrown from a height or normal ground level, bullet fired, any example you can use. Another projectile path, this is body projected from top of the building we have discussed. Another case is body projected from normal ground level. You are gardening the water. You are gardening, you are watering fully using a tube. Another example for projectile motion is body projected from normal ground level. When you water the ground using a tube, it is inclined at an angle theta. That is one example. Ball thrown from normal ground level to some position. That is another example. Otherwise, we call this one as oblique projection. This is body projected from top of the building. Second one, we call it as oblique projection. That is horizontal projection from the top of the building. This is oblique projection at an angle theta with the horizon. That we will discuss. Projectile motion at an angle, otherwise known as oblique projection. Oblique projection. Sir, here you are doing oblique projection. XY, body starting its projection from this point, reaches a maximum height, comes here. This is the maximum height by the body. O, A, B, this is C. H max. This is called maximum height attained by the body. You are projecting the body with a velocity u, making an angle theta. When you project the body with an angle theta, then resolution of a vector we have seen in the first part of kinematics. What is the meaning? That u can be resolved into two components, along the horizontal, along the vertical. Along the horizontal ux, along the vertical uy. Here ux, uy. Here ux, uy. Highest point velocity is 0. So only when you are projecting a body, the velocity goes on decreasing. At the highest point, the velocity becomes 0. So only the body is coming down. So highest point uy, vertical direction velocity is 0. So ux is u cos theta and uy is u sin theta. So as usual, we are going to prove first part, path of the projectile. Path of the projectile. Similar discussion. Displacement x is equal to horizontal velocity into time. Horizontal velocity is nothing but u cos theta. Time we call it as t. So t is x by u cos theta. Equation 1. Next we are going to write displacement equation. What is the displacement equation? S is equal to ut plus half at square. S is equal to ut plus half at square. Displacement equation. S is nothing but x displacement. This is ux, horizontal velocity, u cos theta. Correct? A is replaced by minus g. There, it is not ux, it is uy. When you say along x direction, you can write s is equal to x and ux is equal to u cos theta. This is vertical downward displacement. Vertical displacement, the velocity is uy. Previously, you wrote ux is equal to u cos theta. That is perfectly correct. Now, vertical displacement. You are projecting a body like this. So, against the gravity, it is moving. So, we are putting a is equal to minus g. Vertical direction, it becomes u sin theta. A is equal to minus g. Substitute. What will happen? Therefore, y is equal to uy. Uy is nothing but u sin theta into t. What is t? X by u cos theta plus, that plus becomes a becomes minus g. So it becomes minus half g t square. What is t square? X square by u square cos square theta. X square by u square cos square theta. U cancels. Y is equal to x sin theta by cos theta is tan theta minus, what will you get, ma? Gx square by 2u square cos square theta. Here tan theta is a constant. G by 2 u square cos square theta is a constant. So I can write y is equal to ax plus bx square. This is also equation of a parabola, invert parabola. This is a parabolic equation. So body projected from top of the building also follows a parabolic path. Body projected at the horizontal ground level with a velocity u when you are projecting, it follows a parabolic path. Correct? This is next part. Next, you are going to write maximum height. H max. Maximum height, that is H max, you are going to write. What equation of motion here we can consider? Without the time, we know the equation v square is equal to u square plus 2as. At the highest point, when you say highest point, final velocity becomes zero. Because I already told the body is projected when the velocity goes on decreasing. Maximum height becomes zero, then it is coming down. So we can write v is equal to 0. U is you are projecting in the vertical direction. So u becomes uy, that is u sin theta. A is equal to minus g. S is the displacement here, that is h max. The displacement here is h max, max AB height, maximum displacement. So I can write 0 is equal to u square, that is u square sin square theta minus 2g h max. Minus 2g h max, you bring it to the left hand side. 2g h max is equal to u square sin square theta. H max is equal to u square sin square theta by 2g. Simple. This is the equation for maximum height attained by the body for a oblique projection. Okay. Next, time of flight. First, we have discussed path of the projectile. Second, we have discussed maximum height. And third, time of flight. TF. Time taken by the projectile from the point of projection till it reaches the ground. Okay. So in this case, what equation of motion we can consider? Already we have taken v square is equal to u square plus 2as here. So displacement equation ut plus half at square. Sir, S is a vertical displacement. You are taking the time from O to C. So here, one upward displacement, one downward displacement. These two are opposite, so 0. U becomes uy, u sin theta, because you are projecting against. A is what? Minus g. Against the gravity means A becomes minus g. Towards the gravity means A becomes plus g. That's all. T becomes TF. Right? Therefore, 0 is equal to u sin theta into TF minus of G TF square. Minus of G TF square, you bring it to the left hand side. Half G TF square is equal to U sin theta into TF. TF cancels. TF is equal to 2U sin theta by G. Time taken by the projectile from the point of projection till it reaches the ground. Time of flight. Sir, one more thing also here you can say. Whatever time taken from the point O to the point A, same time it will take from point A to point C. You can use the equation V is equal to U plus AT. V is equal to 0. U becomes U sin theta. A becomes minus G. Calculate T means you will get U sin theta by G. O to A. Same formula A to C. U sin theta by G. U sin theta by G plus U sin theta by G. You are getting 2U sin theta by G. So it is twice the time taken to reach the maximum height. What is the time taken to reach the maximum height means you have to write U sin theta by G. What is time of flight means it is twice, 2t. Correct? Next, horizontal range R. Horizontal range means horizontal velocity into time of flight. Already we know. Body projected from top of the building, we have discussed. Same. R is equal to horizontal velocity is ux, time of flight is tf. U cos theta into 2u sin theta by g. 2u sin theta by g. So I can write 2u square sin theta cos theta by g. That is u square. Trigonometrical formula you know, 2 sin theta cos theta is sin 2 theta. Sin 2 theta by g. That is R. U square sin 2 theta by g is nothing but horizontal range formula. Sir, what velocity I have to project to cover a maximum range? I want to project a body so that after projection, it should reach the maximum distance. We can write. So this is horizontal range. In the diagram, this is horizontal. Okay, fine. Next. Maximum horizontal range or max. What is our formula? U square sin 2 theta by g. This is horizontal range formula. When you say R is maximum, sin 2 theta should be maximum. For R to be maximum, sin 2 theta is maximum. Implies what is maximum value of sin? 1. Sin of what angle should be 1? 90 degree. Sin 90 is 1. That means sin 2 theta becomes 90. When you say 2 theta is equal to 90, I can write theta is equal to 45 degree. So when you project a body at an angle of 45 degree with the horizontal, the body travels maximum distance. The projection should be 45 degree. Any angle you can project, definitely the body will travel. But maximum distance traveling will be at theta is equal to 45. So when you substitute sine 2 theta is equal to 1, how this equation will change? Therefore, R max is equal to U square by G. Because sine 2 theta becomes 1. Correct, Amma? So this is projectile motion. Second part, oblique projection. So we have seen equations of kinematics. V is equal to U plus AT. S is equal to UT plus half AT square. V square is equal to U square plus 2AS by integration method. Then equations of freely falling body. For free fall, what is the equations of motion? There we have discussed, for a freely falling body, initial velocity is 0. U becomes 0. Then we have introduced projectile motion. Any body given an initial velocity and it follows a trajectory, it follows a path, that is called projectile motion. In projectile motion, there are two things, two types. First type, body projected from top of the building. Second type, body projected obliquely, that is horizontal projection from the ground level. In the case of body projected from top of the building, we have proved path of the projectile is a parabola. And we have derived equations for time of flight and horizontal range. Then we have discussed resultant velocity for that body also. So first part. Second part, oblique projection. In oblique projection, we have discussed, again path of the projectile is a parabola. We have proved. Second thing, maximum height attained by the body. What distance maximum the body can cover when you project the velocity u at an angle theta. That we have discussed. Next, time of flight. Time taken by the projectile from the point of projection till it reaches the ground. TF, 2u sin theta by g. And finally, we have discussed horizontal range. R is equal to u square sin 2 theta by g. When you project a body angle of 45 degree, then you will get maximum range. Maximum horizontal range you will get. That is R max is equal to u square by g, because sin 2 theta maximum value is 1. So I can write R max is equal to u square by g. Correct, Amma? So this is projectile motion. Thank you. We'll continue.